Hello everyone, myself Jyoti. Today we are going to learn about a concept called module in Python programming. In this Python module, what exactly we are going to learn in these sessions are what exactly is a module, what is the need of a module, what are the different types of module, and how we can import those modules, and how to import a specific member of a module. Then how we can use a wildcard for importing, and what is this name, which is nothing but the script's entry point. Lastly, we are going to learn about some of the modules like dir, help, and search path. Let's begin with what exactly is a module. Basically, module is a simple Python file which contains Python code, that is nothing but what it may be a packages of Python functions, classes, variables, and combined together in a single unit called code container, which is nothing but your module. Basically, this is used for containing the codes. It acts as a code container. It acts as a namespace organizer where it can create a dedicated namespace which preventing the name conflicts or clashes, and your code will be clean. And this module contains the importable files. That means any Python file can be imported and used as a module by its name, like fibo.py. If it is your module, then it becomes the fibo as a module name. Then, what is the need of module? Modules are fundamental to writing efficient, organized, and scalable Python code. That means basically, modules are a basic or a fundamental part of your Python programming, which is used for efficient writing, organization, and scalable Python codes. They promote the best practices and streamline development, allowing you to build a complex application with ease. Basically, the Python modules are provide you or it facilitate the code reusability. That means we can write once and use anytime, anywhere, and any number of times, which eliminates the redundancy. That means repetition, and also saves the time and effort. Second one, it allows easy maintenance. That means maintainability. Uh, in Python, the modules are nothing but the small part of your program. That means we can break down a large program into a smaller manageable files with simplifying updates and debugging. When the modules provide you the facilities as a standard library access. That means the Python's extensive built-in modules for common tasks like mathematics or any other file operations, they can build and store somewhere else. That is nothing but what? The library. Then it reduces the duplication. That means what? Once you write and you can use many time, which avoids the copying and pasting the code by importing shared functions and classes. These are the some of the importance of modules, that is code reusability, maintainability, standard library access, and reduced duplication. Next, we'll go for what are the different types of modules which are available in Python. First one is a built-in, second one is user-defined, third one is a third party. Let's start the definition of what exactly these three types are. The Python module system is versatile, encompassing the modules pre-installed with what? Python. Or we can create yourself or external libraries from the other other community. That means what exactly the built-in module? Built-in module which is comes in a pre-installed with what? Python. That means whenever you install a Python, then this built-in module will be part of your installation. And that means what? They shipped directly with a Python. For example, we can have a module like Math, Sys, OS. They instantly available for use. No need to create or install something else. They will be the part of Python installation. Second one is user-defined module. User-defined modules are nothing but user means what? The user can define their own modules based on their requirement, that we can call it as a custom modules. Also we can call it as, these custom modules are created by using the files with the extension .py, and these are basically created based on your requirement to support a specific project needs. Next one, you can organize your own code base. Then third party modules. The third party modules are nothing but what? External libraries from other community. That means somebody already created, then you can use them. That is nothing but what? They are the external packages from the Python community. That means the Python developers community. Then how we can use these external or third party modules? Just by installing using what? Pip. For example, matplotlib is one of the module which is helps to plot the graphs and all. If you want to use this third party module, then you have to use what? Pip. Then it extends the Python's capability significantly by using what? External. Basically, Python prioritize the built-in modules, then such as your own system path, that is sys.path for a user-defined and third-party modules. This is regarding the types of modules. Basically, we have the three types of modules in Python. One is built-in modules, second one is user-defined, third one is a third-party. Built-in means it will be the part of your Python installation. No need to install or install again. Next one is a user defined, where the customer based on their or the user based on their specific requirement for a specific project, they can create their own user defined modules. Third party, that means it is created by the Python community based on your requirement. You can use any of the third party or external packages just by installing like using pip. Next, we'll go how these Python modules can be imported to reuse. This is basically simplest way to use modules is to import its entire content. That means whenever you want to use some module, just you have to what? Import it. Import, I think you all have studied C programming language, where if you want to use any of the already existing header files, we are going to use like hash include stdio.h, right? A similar way, instead of hash include, here in Python we are using import. What is the then syntax of importing whole module? That means the module which contains the functions, variables, classes and everything, the whatever is a part of that module, the whole thing will be imported into your newly developed Python code. How we can import? This is a basic structure or a basic syntax, where we are using what? Import. It is a keyword space the module name which you want to import. Basically, this statement imports the entire module, making its content available under the module name in a namespace. Then how to access members, or if you want to access any particular function of that module, then you can use what? Module name dot that function. Okay, here the module name followed by dot is used to access the specific function or variable within that module. Let's consider an example here to calculate square root of 16. For square root of 16, basically square root is a mathematical function. So first you have to import what? Math module, that is import math. Then you can call in that math module, which is a specific function we need to find out the square root of 16. That is what? SQRT, which is built in. SQRT, then here we have to specify the input. Here our input is what? 16. Okay. In this case, the modules are only imported once, and we can use these imported modules as many as time you want. Clear? This is regarding what? Import of module. Then, how to import in the previous thing we have learned how to import a whole module. Now you are going to see how to import a specific function of a module. Okay, first here, first we can say precise import. Okay, how we can do here is module 1, that means where you want to import. Okay, then import keyword, then the which all functions you want to import, functions or member you want to import. Let's consider name 1 is a one of the member, name 2 is a another one. Okay, the second, this is one way. Second one, we can use direct access. Here once imported, use names directly, for example sqrt25 instead of mat.25. Okay, next, third one, clean namespace. It basically modules are for clean namespacing purpose, which reduces the potential name conflicts, and especially in a larger and larger projects. Then how we can do here is, if you, here is an example where PI and SQRT are the members of math module. Then how to import this PI and SQRT? Okay, for that, here we can use from math import, which members you want to import here? PI and SQRT. Then directly next in future, we can directly use as PI or we can use as SQRT. Clear? Okay. Then here wildcard is nothing but what? Star, or you can say asterisk. Okay. What it exactly do is, it is going to import all the public names, all the public members of the module directly into your current namespace. Clear? Okay. Then how to do this one? From which module you want to import all the public members, that module name, then import keyword followed by star or asterisk. Okay, this command imports all the definitions or all the contents which are publicly available from the module name into your current scope or into your current Python code. The meaning that you can use them without any prefixes. Okay, while using this wildcard, we have to be very cautious. What we have to do here, the first possibility is namespace pollution. Here it can overwrite the existing file names or introduce the unexpected conflicts. Second one, readability. It becomes unclear where the functions or variables are originated, which hindering the code comprehension. Last one, debugging. The tracing the errors becomes harder when the name lack of clear sources. Okay, these are the three cautions we have to take care of these three things while using the wildcard. Okay, next, sometimes what happens, the module name will be large, bigger one. It is very difficult to remember the complete module name. There may be a chances of spelling mistakes and all. So we can make that module name in a shorter. That means we can give the alternative name for a modules. For that, we can call it as a aliasing. Aliasing modules are nothing but what? Alternative names or shorter names are given for a existing modules. That means aliasing allows you to give an important module or a specific members a different, often shorter names. This is particularly useful for a long module names or to prevent the naming conflicts. Then how to do this, how to give the alternative for modules, like import, it is as it is, name of the module which you want to import. Then you have to use the keyword as alias. Alias is nothing but the alternative name which you want to give. Okay, let's consider here is an example. NumPy is a module which are basically used for arrays. Okay, here NumPy, I can give the alternative or aliasing name for NumPy is NP. Okay, then how to give it as import NumPy as NP. In future, whenever you want to use any of the members of NumPy, instead of using NumPy, you can just use NP. Okay, here how we can use is, here is an example. Instead of using NumPy, what we are using here, NP, which is an alternative name for NumPy, dot the member of NumPy, that is array, instead of NumPy dot array. Clear? Aliasing enhance the code readability. That means what? Instead of remembering a long module name, it is easier to remember a shorter ones. Next, this is regarding what? Module aliasing. Here we can do the aliasing or alternative names are also given for the members of the module. Then how we can do is the from which module you want to import, then which member you want to import, then alternative name for that member. Okay, it is nothing but what, just renaming of a specific member. It may be a function or a variable on upon import. For example, here collection is a module. Okay, from where you want to import? From collection I am importing. What we are importing? Counter. It is a member of a collection module. Okay, counter, for counter, what alternative name you want to give? That is what? CNT. So now onwards, after specifying this statement, now onwards, whenever you want to use counter, just you can use it as a CNT. Clear? Okay. Next, we'll move on to what? Name. Okay, as in the case of what? C programming language, Java programming language, main function is a entry point for what? Execution. In the similar way also in Python, modules has a special built-in attribute called name. Okay, two under continuous underscores, then followed by again two continuous underscore. This attribute determines how the module is being executed. Okay, as standalone scripts or as a imported module. That means what? If you want to use any of the module, this name attribute specifies whether that module has to be executed as a script or it has to be imported. Okay, when a module is run directly, then you have to write it as Python. The script what you want to run directly .py. Its name attribute is set to main. Okay, that means what? This particular script will be run independently or execute independently or directly. That will be the entry point. Okay, second one, when a module is imported into another script, then what name attribute value of the name is set to module's actual name. That means what? Here we are going to use only the name of the module without any .py extension. Okay, then how to use it is, if name, it is a attribute, what is the value here? It is a main. Then if it is a main, then your module code, that file will be run, that is treated as a script, then that is going to be executed directly. Clear? Okay, next, if name is equal to, okay, if name is equal to, then your script name directly without any extension, then that module will be imported. That module will be imported and it is used by some other Python code. Clear? Okay. Next is navigating modules. Navigating modules in Python, we have three navigating modules like dir, help, and search path. Understanding how Python finds a module. In Python, how we can find out a particular module and inspecting their content. That means what all are the contents of a particular module. Okay, let's start with the dir. Dir is nothing but directory. In short, it is dir. If you use this function or a module, it is going to list out all the valid attributes like functions, classes, variables of a object or a module. So for example, if we want to see what are the functions, classes, variables available in the math module, then we can use is like a dir into the bracket math. Then it is going to list out all the contents of math module. Math, that means what? It contains the functions like sqrt, sine, cos, tan, okay, power, like that. Whatever the functions are there and variables, classes which are part of math module, they will be listed out if you use dir. Okay, next is help. Help, it is going to provide detailed documentation for a module, function, or a class. For example, what exactly math module is going to do? What are the contents of module? dir only list out. Help, it gives the detailed documentation. For example, if you want to know about sqrt, member of math module, okay, then how we can give here? It is going to generate a document related to what? Regarding the sqrt, that is help into the bracket math.sqrt. Then it is going to generate the document, detailed document regarding what? Sqrt. Clear? Then next is what? Search path. The module search path, when you import a module, the Python looks in order to import that module. First, it is going to search in a current directory. Current directory is nothing but folder. Current directory, the directory where your script is being run. Okay, next, Python path, that is directory specified in the Python path environment. Then it will search in the standard library paths. Directories where Python's built-in modules are installed, accessible via sys.path. Okay, you can inspect or even modify sys.path if needed, though it is generally recommended to manage module path using the virtual environment. Okay, this is regarding what? Navigate. Basically, here you have to remember what exactly dir going to do and help going to do. dir list out all the contents of a particular module. Help is going to give a detailed documentation regarding a particular content of a module. Then comes the search path. How to search? Python going to search a module regarding the module when we import it. First, it is going to search in a current directory. Second, it is going to search in a Python path. Third, it is going to search in a standard library. Clear? Okay, I hope it is clear. Let's take a small MCQ test here. We'll start with the first one question, that is, what is Python module? Okay, here we have what? Four options. One is graphical interface, a text editor, a file containing a Python definitions and statements. Last one, compiled binary file. Then what is Python module? Yes, it is right. It is a yes, it is a file containing the Python definitions and statements. Okay. Wait a minute. Okay, next question. What is the correct file extension for Python module? Let's have options. Dot mod, second option dot module, third option dot py, fourth option dot txt. Which is correct one? Yes, it is C. That is what? Dot py. Okay, next question. Which of the following is a built-in Python module? Let's have our options. NumPy, random, myutils, calculator. Which one? Yes, it is B. That is random. Fourth question. What will be the following code output? Here we have what? Import math. That means we are going to importing a math, and we are going to write a statement like print math dot sqrt 16. That means it is going to find out sqrt, that means square root of 16. Then what are the options here? We have what? Option A 8, option B 4, option C 2, and option D is error. What is the answer? What is the square root of 4? It is, sorry, square root of 16. It is 4. Last MCQ. Which statement imports only sqrt function from math module? Let's consider the option. Import math.sqrt, import sqrt from math, import sqrt, using sqrt from math. Which one? Yes, it is C. From math, import sqrt. Okay. I hope the session is clear. It is regarding the Python modules. These are the references we can go through. Thank you.